Hey gang, that's because that's what I do in the in the videos. Yeah. So what we're going to do today is we're going to talk about density calculations, and for the people who are watching the video, this is something that we're just doing kind of in class. So here's something that I want to talk about first, because we've been going over density and we've been going over mass and volume, but now we're going to kind of take those two ideas and put them together. So we've talked about mass. You guys watched the Eureka video where mass is just how lazy something is, how much inertia it has. Another way of looking at it, it's how much matter you have and things. So if I'm talking about mass, there we go. So some of the ways that I can measure mass would be like with grams. I could do it with kilograms, things like that. It's similar to weight, but it's not the exact same thing, and we'll start talking more about what that means. Now, volume is that for me?
No, this is for me.
I guess so. All right, those of you who are watching on video, that was just a very disappointing moment for things. But yeah, volume is just how much space something takes up. So if I go and for lunch I have a 2 liter of Mountain Dew, all right, the volume is how much space that liquid takes up. So that is if it's for a liquid, it's done in things like milliliters, liters. If it's for solids, then we use what's called cubic centimeters, which is written as a cm and then to the third power. Because remember when we were doing the volume of a box and the volume of a cylinder, like for a box it's length times width times height. Well, if I measure all of those in centimeters, it's centimeters times centimeters times centimeters, which equals centimeter cubed. All right. But the big idea here is that density is how much stuff is packed inside of an object, and that has to do with an object's mass, and it has to do with volume. Because remember when we were doing the balance and how we had the 2 glass marbles over here and like was it 13 or 14 of the wood marbles? Yeah. When they balanced, what did we know about their mass? The masses were the same, but were their volumes the same? No, they had different amounts of space that they took up. So which one of those, the glass marbles or the wood marbles, had the stuff packed together more tightly? The glass. The glass, because it took that mass and packed it into a smaller space. So the glass was more dense than the wood. Yeah. So let's talk about how to calculate that. And if you've watched the videos, this is something that'll help you out. This is a little way to remember how to calculate density, mass, and volume. So if I'm trying to calculate density, if I look right here, so here's density, okay? Density equals mass divided by volume. So density equals mass divided by volume. Do you see how I got that? So density, so we take this out and this out, and so we have mass divided by volume. Let me see if I can erase that. Nope. No good. All right. So now let's say if I want to find mass. So I know that density equals mass divided by volume. But now if I want to do mass, that's supposed to be an m right there. Just so you know. Just kind of play along, pretend. All right. So if I have mass right here and I look at my little triangle, so that triangle points to density and volume. What does my triangle tell me? How do I calculate mass? How do I do that?
Volume times density?
Yeah, volume times density. Does it matter which order I do it in? No. Okay. So mass equals density times volume. So the last one, if I want to figure out volume, and I have my mass and I have my density, so I just kind of look over there. So you're saying volume equals what divided by what?
Mass divided by density.
Mass divided by density. Very good. Wait, no. Mass divided by density. That's supposed to be a D. In case. All right, so those are the three different formulas that we're going to use. What I want to do here is give you some different example problems, and we can kind of do those together before you guys are doing those on your own. So here's the first thing. And every time I do this with my students, I get people who are like, oh, Mr. Spencer, this is so stupid. Why do I have to go through all of these? Look at me. Okay. Do you trust me?
Yeah.
Justin doesn't, but a lot of the other people do. Okay? So, but this is why I ask you to do this. These are simple problems, but if you get into the habit of doing this, life is going to be a lot easier for you because it's going to have everything be organized. All right, so go back. So whenever we do a sample problem, we always start off with, what do you know? Okay, what do we know and what are we trying to find? Then we go and we find the equation and then we show our work. Like I said, it takes a few extra steps, but it's going to save you a lot of grief on some of these problems. So let's do some of these together. Did I go too fast?
Yeah.
Okay. So what do I know? What am I trying to find? What's the equation? And then I show my work. And we'll do each one of these together, so you'll get a feel for this. So all of you who are watching this on video are just waiting. Waiting. Am I allowed to go?
No.
How about this? What I'll do is we'll go through each one of these and I'll put all of the steps so you'll be able to see how that goes. All right, so here's the first problem. We're going to try to solve for density. All right, so problem number 1. I have a piece of metal that has a mass of 24 grams and a volume of 16 cubic centimeters. What's the density of the metal? So first thing I'm going to do is I have to figure out what I know. So what do I know?
Mass is 24. Volume is 16.
So Jay, what do I have?
You have a mass of 24 and a volume of 16, so you have to do 20
Okay, now 24 what?
grams.
Mass of 24 grams. And what else do I know?
You have a volume of 16 cubic centimeters.
All right. So I like to underline those just because it's easier for me. But I also write them up here. So I know that mass, and I'm just going to write that as an M. Mass equals what? 24 grams. And I have volume equaling 16 cubic centimeters. And there I go, having a hard time writing my M's again. Now, why do I use M and V? Why can't I just put 24 grams, 16 cubic centimeters? Jarek, what do you think?
You need to know the difference between mass and volume.
Yeah, you need to know the difference between mass and volume, and it's going to be really helpful when we set up our equation. So those are the things that I know. What don't I know, Kyle? Or what am I trying to find?
I'm trying to find the density.
Okay, so I'm going to put D equals, and then just a little question mark.
Do you use this triangle thing?
So now, okay, so now go back to the triangle. Here, I'm going to try to do this. Okay, Kyle's helping me out here. So density, and what was up top? Mass, volume, and it was times, wait, that's a plus. It's supposed to be times. Wow, I am really screwing this up. Okay? All right, So what is it that I'm trying to find?
Density.
I'm trying to find density. So if I look at density over here on my triangle, how do I calculate density?
Mass divided by volume.
Allie?
Yeah, that's divided by volume.
Okay, so it's mass divided by volume. And it's really important. I know you guys, I know it takes extra time, but if you do this, it makes things so much easier. I write out the equation that I'm going to use. So density, D equals M divided by V. And now I just plug things in. So I'm going to say density equals, so mass is what?
24 grams.
24 grams, and it's important to put the units on there too. And volume is 16 cubic centimeters. So then I go and I plug that into my I plug that into my calculator. So 24. You know what? It really helps if you turn on the calculator first. 24 grams divided by 16 cubic centimeters. Is anyone else doing this? Okay, let's see if we get the same answer. What did you get?
1.5
Okay.
grams.
There you go. 1.5 grams per cubic centimeter. So that's that's supposedly the answer right there. All right, so that's how we do density. Does anybody have any questions about how we do that?
We just put both of the grams and centimeters on there.
Yeah, put grams / cubic centimeters. All right, so here's the next one. We've solved for density. You know, density equals mass divided by volume. Now for this one, it's going to be a little bit different. This time, we're going to be solving for something else. So let's see, what do we know? We've got a piece of metal has a density of 10.5 grams per cubic centimeter and a mass of 2 grams. What's the volume of this metal? So what do we know? Give me hands.
The density and the mass.
Okay, Kyle?
Mass and density.
Okay, so I know density equals what?
10.5.
10.5 grams per cubic centimeter. Now I want you to actually write that down. I want you to get in the habit of writing what you know down. What else do we know? Oh, wait. You had your hand up before. Okay, what else do we know? We know the mass. And in this case, so M equals what? 2 grams. Okay, so we know density, we know that mass equals 2 grams. What are we trying to find?
The volume of the metal.
The volume.
We're trying to find the volume. So volume equals, I'm just going to put a question mark there. All right? So we look at our little triangle, and I'm going to have Kyle help me out again. So I have density here. Kyle, what was on top of our triangle?
Mass.
Mass is up here. Volume is over here. So times, divide. Okay, so this time we're trying to find volume. So if I have if I'm trying to find volume, how do I set this up? Volume equals what? Okay.
D over M. Or M over D.
M over D. So mass divided by volume. You see where we got that? So now I go and I plug in. So I know that my mass is 2 grams. Density is 10.5 grams per cubic centimeter. So this is going to be interesting. 2 divided by 10.5. Did you get it, Allie?
Yeah.
What'd you get?
5.25.
What was it? Say it again.
5.25.
Is that 2 divided by 10.5?
That's the other way around.
Why?
You gotta do the 2 on the top because the mass is on the top.
It's like 0.1.
Yeah. 0.19. And what would the units be for volume? Centimeters cubed. All right, so the volume is 0.19 cubic centimeters. All right, last one. So this is number 3. We've got a piece of wood, white pine wood that has a density of 0.430 grams per cubic centimeter and a volume of 50 cubic centimeters. What's the mass of the wood? So let's go through and let's figure out what we know. All right, so first thing, what do we know? Melody, I'm going to pick on you.
Okay.
What do we know?
We know that we already know density and we know volume.
Good, so we've got density and we also have volume. So density is 0.430 grams per cubic centimeter. We know that volume is 50 cubic centimeters. And what is it that we're looking for?
The mass.
We're looking for the mass. So we're trying to find mass. So that's our question mark. So if I set up my triangle again, and because you guys already have this written down, it'll be okay. So density is over here. What's over here?
Volume.
Volume.
Mass.
What's over? And mass. And I remember this one. We've got times and divide and divide. So this time we're trying to find mass. So mass equals what according to our triangle?
Density times volume.
Good old density times volume. And in this case, our density is 0.430 grams per cubic centimeter times, and I don't know why this is just getting worse as I try to write. And then our volume is 50 cubic centimeters. So 0.430 times 50, what does that give us? What is it? 21.5?
Yeah.
Yeah. So our mass is 21.5. And what are our units going to be? Grams. All right, guys. So that is just an example of how to calculate density, how to calculate mass, and how to calculate volume. You guys, remember, you get to use your notes on the test, so that might be helpful to have that. What I'm going to let you do now is work on whatever you need to. There is for those of you who are all caught up and are looking for the new stuff, we've got the density calculation notes that we just did, and then we have the density calculation problems that are all in Schoology. All right, go for it, guys.